It's Don here from the board. Thanks for coming along and checking out this video. This is going to be a build guide on how to assemble the NavPad Macropad. So the background for the NavPad Macropad was that PCBWay had contacted me and asked me to enter their PCB design competition. The requirements was that the PCB had to be within 100 by 100 millimeters and could be anything that I wanted. Now, they'd contacted me quite close to the actual entry completion date, and I didn't really have anything in particular in mind, so I thought I'd just knock together a very quick 12-key Macropad. I submitted it, and of course I didn't win, but that's irrelevant. PCBWay were also really happy to sort of get me on board and being involved with their competition, that they wanted me to get something made from them so that I could actually review it. So I thought, you know what, the actual size of the PCB wasn't very big, so it wasn't very expensive, so I actually put in an order and got them and did that review video of this particular Macropad. So now we're just going to go through what is required to actually build one, and then I'm going to build one essentially as this video. So let's switch over to the desktop now and have a look at what you're going to need, or at least some of the things that are going to be involved in actually putting together this Macropad. So here's the actual PCB itself. It's a 12-key PCB, 6 in a block in a straight grid array, and then you've got something that's designed so you can have arrow key movement as well as extras, or the whole lot can be a full-blown Macropad. The back of it does have build instructions and build order, so putting in your diodes, the Pro Micro headers, putting in your switches, and then the Pro Micro, and it's designed that way so you don't necessarily have to have a plate or case. You just need two of these to do it with the PCB style. What I do have here though is some acrylic plates that's been kindly cut at my request, and of course paid for, by Laser Ninja, who's a local Australian folk. So, shout out to you, Laser Ninja, for getting these turned around really quickly for me. And the test fit that I did with them, with the switches, seemed to be perfectly fine. I've got 12 keycaps here. I'm using DSAs, blanks, just because I can. I've got my soldering iron. Over on this side, we've got a Pro Micro. I'm going to be using and testing the black Pro Micro for this particular build. I've got 12 Gatoron blue switches here. I've got a sheet of bump-on sticker feet, so I can put it on underneath so that the screws aren't going to be scratching the surface that they're going to be resting on. I've got 12 diodes, a reset button that I'll solder onto the actual Pro Micro, 8 screws, and 4 standoffs. Now these are M2 sized standoffs because I built the actual mount points for these with M2, including as well as on the plate. And lastly, I've got my own 3D printed diode bender, so you can bend diodes en masse relatively quickly with this device. So what I'm going to do to start with is I'm going to put that away, and I'm going to move these keycaps because they're going to be essentially the last thing that go on. They can go over there as well with the bump on. I'm not going to need those immediately, so that can move off the stage. That can move. Oh, and of course I've got some solder over here on the side in my little caddy that I designed and had 3D printed as well. Switches don't need to be in a bag. Let's empty those out. Bag can go away. That can go for the moment. So let's just start to line these guys up in my diode bender. Now, of course, if you're only doing a very small amount like I am here, 12, you probably could just bend them easily by hand, but I want to just show off this tool anyway because I went to the effort of actually making it and I like to use it. It's pretty cool. It gives fairly consistent results in the bending, which yeah, it's always nice. So once you line all of these diodes up, you'll note that I'm actually putting the orientation the same way. That's a little bit of OCD. You don't absolutely have to, as long as you center them. They should bend fairly evenly. I'm just going to push them all to one side to line up, and then I'll back them off into the middle somewhat, so the top piece can line up with it well enough. There we go. And just give them a squeeze. Voila, the legs are all up, and then just an inward touch on those to bring them a little bit easier. Okay, done. Fairly even. That can go away as well. Now, normally I would actually have my quad hands here, my helping hands, but I haven't because with a plate build, and if it's not PCB mounted, when I flip it around, it all tends to fall out. But it means, of course, when you solder the the diodes to start with, you will need a bit of an elevated lift, I suppose is one way of describing it, so that your diodes aren't going to be pushed up and out. Now, of course, with the actual PCB itself, the orientation of the diodes should be that the black line is towards the thicker line of the diode. This PCB design does not have LEDs in it, so you can't get them mixed up because there's no LED holes, and there's also no resistor holes to get mixed up in as well. So let's just thread our 12 resistors, because you're going to have, 12 diodes. You're going to have one diode for each key switch in this very simple matrix. Very simple design. Make sure that they're in the correct orientation. The footprint that I use for these PCBs is also matched to the width that I've got my bender designed to, which I believe from memory is about 8 mil, 7.5, 8 mil. You can have other footprints for diodes. It depends entirely on the person who designed the PCB and what footprint library they used. So just be aware of that. If it obviously is not the same size, then my diode bender wouldn't work very well, and I'd have to either redesign it or hand bend them for a particular board. But I have found that around 8 mil is fairly standard for diodes. So, and this particular footprint that I've used also has the SMD components as well, so you can see the actual pads there if you wanted to use SMDs instead. Surface mount devices. Oi! Okay, that was unintentional, but thankfully none of them popped out. Too badly. Just pat them back down again. Thankfully there's nothing delicate on this that would break. These are glass bodied diodes, so they're quite hardy. Quite hardy. Right. So get that last one in. And it's down, so they're all sitting flush. Now, will they all fit in that? They will not. So what I'll do is I'm going to prop it with a tape roll. Is that going to be the same height? That's not going to be the same height. You can't really see it off the screen. Well, you can't see it because it is off the screen, but on my cabinet, I've got a whole bunch of rolls of tape. Right, there we go. So that should give me the support that I need to solder these guys down. Of course, I could pull out my quad hands, but I'm just a bit on the lazy side. So there is my iron TS100. I do like it very much. It does the job very well. It's relatively affordable, it's lightweight, it's handy. Replacement tips are readily available in different sizes and types. So that's my preferred iron at the moment. I do have a Yihua 936, whatever it is. It's a clone essentially of the Hako soldering irons. So, but this heats up very quickly. You can see it's gone from nothing to 290 within seconds. It just requires like a laptop DC power supply in the back. I think it's 12 volts to 24 volts, and it changes its heat ramp based upon what you're providing it. So it's always clean off our tip and then re-tin it. Rightio, so now that's nice and good. Just move that a little bit to the side, and I'm just going to tack wire down my diodes. I used to actually solder on the other side, but then I was shown this way of doing it, and it does actually give you very neat sort of joints. When you flip it over, you will see that some of it will wick through, so as long as you don't over apply on one side and the wicking through, it shouldn't end up with a massive blob on the other side, and you'll still have good contact and continuity. And this way your diodes will also sit flat, because when you flip them upside down, unless if you do a lot of extensive bending of the legs to try and stop them from falling out under gravity, or taping them down, or all sorts of other things, you'll get a much neater, nicer look. Now, because I'm also soldering very small amounts, my iron is able to keep up. I don't have to really let it sort of retain its thermal mass by stopping, and I'm also running at 310, which is a little bit on the high side for what's absolutely necessary. I think you could probably run around, 300 would also, this solder works well at 300. Right, so let's just put that there for the moment. Let's just flip it around and check. So we've got some solder that's come through on almost all of those. Yeah, I would say that I'm relatively happy with how they've gone. What I will do though, and this is just a habit of mine, is I will actually go through and retouch and reflow every one of these joints, just to make sure that none of them are actually going to be a cold joint. It's just touching it, letting it soften up, getting that liquid look to about it, kind of like the Terminator in Terminator 2, the T1000, and that way I know that it's getting good joining happening between the pad and the component. You can also do this to reseat your diodes, so if any of them are sticking up at a funny angle, with of course care, because your finger's going to be right next to a hot component, so that you can actually press the component down once you've reflowed one side just to flatten it up, and then of course press the other side to reflow it as well. But it's not absolutely necessary for this one right now, because they're all sitting pretty good. So if I hold that, you can see they're all pretty flat. Fantastic. Now, I did forget, you will need some side cutters, because mine are typically quite handy nearby. So just some side cutters, and that will enable you to trim your pins. Well, not pins, your diode legs. Wait, what have you done? Now, safety glasses is always recommended. I don't wear safety glasses because I wear normal glasses, but that's really no excuse in some circumstances. You'll note that I'm very careful at the way I'm pointing when I clip these. They can bounce and fly everywhere, so you do have to make sure your eye safety is right up there. Now, if you have like a really strong magnet and you clip it near the magnet will actually pick up these diode legs as well, and save you from potentially them flying everywhere. If you do wear glasses, you do have to remember that glasses aren't going to give you protection if your eyes aren't covered with enough coverage. When I was doing chemistry in my uni days, they actually have a diagram on the wall and you have to hold up your glasses to it at the start of the session to show the lab demonstrator that your glasses actually have enough coverage, and it's got like a grid with a minimum coverage size. So if you had really fancy glasses, you know, stylish glasses that didn't cover it, then you would have to wear safety goggles on top. And that actually influenced me enough to, when I got a new pair of glasses, to not get fancy glasses and made sure that they were large enough to cover that size. Only because wearing safety glasses over glasses is a real pain. Okay, that's done. And all of those diode legs, just drop one on the ground. I like to keep them simply because they are useful for other things. You can do socketing, you can do jumps with them, you can do wire jumps with them, so forth. I do have a packet somewhere around here where I keep them all. Come on, there we go. I've got a bag of hundreds of diode legs that I keep. I suppose later on, if I want to, I can just chuck them anyway, recycle them or something. Right, now comes the plate part. So here's the plate, and it's actually, we're going to flip that around and it's going to sit on top just like that. But now we get to peel off the protective layer, because we don't want that still on it once we complete the build. Otherwise that'll be a real pain to have to peel off in one of the orientations. So there you go. Get back here. Now, of course, I'm leaving fingerprints and everything else on this. I'm not too fussed about it myself, but I know some OCD people would be like, you should be wearing gloves. It's a functioning pad. I'm more about functioning than form and beauty, but that's just me. Of course, if you are much more sensitive about fingerprints and stuff like that, then yeah, you probably should wear some gloves. Right, so there's my plate, and I'm going to start feeding my switches through it. Now I know that my switches are actually facing with the pins at the top, because that's how they're going to go through the PCB. Now, if you're using a 3D printed version of this, either without a bottom piece and it's like a plate case, or if you've got 3D printed plates, it's exactly the same. If you're using switches that are PCB mount and you're not using the plate, then obviously you would need to skip this particular step because it's not relevant to you. So just going to keep putting these guys in. That's right, I do need to put my headers on, don't I? I forgot about that. If I don't put my headers on, I'm going to be in trouble because I won't be able to put my Pro Micro on at the end. Isn't it good that I think these things through? Not to mention the fact that it's even printed on my Macropad. Look, it says diodes. It says diodes. Come on to focus. Pro Micro headers, switches, then Pro Micro. So I nearly stuffed up my own build on a design that I made. How embarrassing would that be? So there's the Pro Micro headers, and there's the Pro Micro. So what we need to do is flip it around to the back. We'll install the headers. So they will be sitting like that. Long headers out. Come on, there we go. I'm going to drop my Pro Micro in the correct orientation. So raw and transmit, which we'll see is raw on this side and transmit on that side on the silk screen here. I'll drop them in, get it lined up, and then I'll use a bit of tape to hold it so that I can flip it upside down and then actually solder it into place with this Pro Micro taped on. The reason why I do that is because if your headers move when you're actually soldering it, you're not going to be able to get your Pro Micro on afterwards, which would be also a really bad idea. There we go, it's upside down. I can tuck that in, and now I'm just going to wake up my iron. It's gone down to 200 degrees, but now it's going to come up to temp. .310, we're good to go. So let's just tin that again. And away we go. Now, doing these header pins, having a reasonably fine tip is advisable, because then you've got much better control and you're not going to bridge your pins. Bridging your pins is a real pain, because then you've got to desolder both pins typically and then clean them up and then redo them. Desoldering these things are a absolute pain. And of course, when you're working with small components, make sure that you do clean your iron tip regularly so that you don't build up a blob on it, because that will also increase the likelihood of accidentally touching components around it and bridging, which is exactly what we do not want. Two more to go. There we go, that's the last one. Now, just like I did with the diodes, I like to go back and just retouch them, reflow them, make sure that they wick down in properly, have a good amount of contact. It's only about a second or so on each one, very quick and easy, especially if your iron's up to temp. And it also allows you to pull away any excess solder that might be sitting on the pin, actually, because it'll come up off with your iron tip. It'll wick down, it'll form a nice conical connection, and any excess that the solder doesn't believe it needs to have on it will actually come up and off with your tip. It's always better to be sparing, of course, because you can apply more. It's a lot more of a pain to have to take excess solder off later. Okay, there we go. That part is now done. And flip that back around. We'll peel the tape off, and you can see the Pro Micro is lifting off and going back on pretty readily, which is great. That's exactly what we want. So let's just put that back down. We'll flip it around, and now we'll get our plate with switches in it and line these up. So now I know that people are going to be like, oh, you should only do the corner ones first and all that kind of stuff. I know this is good because I tested it earlier and all of my pins should come through okay. And there's good practice and then there's bad practice. This is probably a not great practice. So what people are talking about there is you put in the corner ones first and then you solder it so it keeps everything in place, and then you pop in the others. For a small build like this, I don't feel it's necessary. For a big build, yes, I would definitely agree in doing it that way. So now I'm just going to have a look at an angle, and I see that all of my pins have come through. None of them have missed their holes and have been bent in between. You'd feel it anyway. So this is when, if I had PCB mounted switches, I would actually have it in the helping hands, my quad hands. But because if I push on this PCB part without anything underneath right now, as I can often do when I'm soldering, it will actually pop the switches out of the plate, and I don't want to do that. So I have to rest it on a firm surface and make sure that it's nice and firm and solid, and then that way when I solder it down, it will be just a-okay fine. Now I'm going to actually flip this around to make it easy to get in between the Pro Micro for those ones, and then I'll turn it around once again, and now we're just going to solder in these switches. Making sure that we get a good contact. With this particular footprint that I'm using, it actually caters for MX and Alps. So other footprints that people will use may be MX specific only, and so they'll look slightly different and they'll be slightly different in size as well. So you may have to use more or less solder to actually to fill them, to bridge their requirements. With bigger switches, well, with bigger switch prints, you will obviously need a little bit more to get a really good contact and that sort of conical joint forming. But yeah, you can always, if you're not happy with it, you can always desolder it anyway and then resolder if you need to. With a good solder sucker, that is. Hey, what are you doing? My solder is getting caught on my spool. There we go. Just gonna heat that up a little bit and apply a bit more. Okay. The other thing about soldering without the quad hands is it means I can do these kind of rotations a lot easier. I don't have to worry about having to reposition the clamp and stuff. But if you're doing a big PCB that's already got components, surface components on it, on board microcontrollers, then it's never really going to be an issue because you don't have header pins in the way. Alright, 6 more to go. Okay, that looks to be good. Just checking how much is on each of these, and of course go back and retouch them as well as necessary, just to get them to be happy. It's not absolutely necessary. If you're confident with your soldering work, then you don't have to do it. It's just one of my little quirks and habits, personal preference really. I know that some people don't really like doing that because they're also concerned about overheating and lifting pads. This is really more an experience point because I know that when I heat them up to a certain stage and they have a certain look, it's done. I don't leave them on any longer than that. But for some people, if they're a little bit concerned, well, I can appreciate that, and it's not an absolutely necessary step. It's just if you do find later on that you don't have good contact or your switch is behaving funny, you're going to have to take it apart and check and reflow the joints as well. So it's just something to be mindful of more than anything else. So there we go, switches are all in. That's half the job done. Now it's time to put our Pro Micro on, solder the Pro Micro, and then put the bottom on. We're in the home stretch. Home stretch. Make sure I've got enough solder slack there. Try not to touch any of the components on the actual Pro Micro and overheat them as well. This part is definitely easier on a helping hand. Uh-oh. Kind of bridged that one. That's exactly what I was afraid of. So there we go. When you do have that happening, what you can do is you can put your soldering iron in between the two and then draw it up, because any excess will come up with your tip as it wicks up the pin, and then it'll break the actual the blob between the two pins as it thins out, and then you should be able to remove that joining between the two. Okay, so they all look pretty good. Let's switch around to the other side. Come on. Okay, so all the pins are soldered. I don't know if that'll focus very well. You can see they've got a bit of a sort of conical tip about them. But what I will do, of course, is I'm just going to go back and retouch them. And I'm actually going to wick them upwards as well. So any excess that hasn't been pulled into the actual joint will go up the pin, and then I'll get really lovely looking conical bases. can see it takes very little time to heat them up because there's that little solder in them. And they're probably still warm as well because I've done them just very, very recently. There you go. The Pro Micro is done. Now we need to put a switch in. So the switch will go in between ground and reset. What I like to do with these guys is I'll bend in one side. I could cut them off, but I find bending them works fine. And then, so I've actually bent one side of the legs in, and then I'll pinch the legs in a little bit as well, just to make them a little bit easier to work with, and it will actually sit against the componentry just like that. Now, this is where the no silkscreen is a little bit annoying, but I always like to confirm where the actual positions are on the silkscreen, but the blue one has it on the top, the black one has it underneath. So you might want to have a reference diagram or something like that. And the ground and reset is the second and third from the top on the right hand side when you look at the chip side. So what I want to do is I want to put it on the second and third, just like that. Okay. Now, that's going to be sitting okay. So I'm going to actually pre-tin my pin, and then I'll actually put the switch onto it that way. Second and the third. Oh, see, there's I'm just gonna, if you have tweezers, you probably could do this with tweezers. If you don't want to mess with tweezers, then hey, there we go. So I've done one. It's not super pretty. I don't claim to be the prettiest of soldering. I like to think that I do decent soldering, but pretty is not a prerequisite. Hey, stop bridging to raw. Alright, I need to fix this. Get away from the raw pin. Seem to be making it worse. Of course, I don't want to overheat it, so there we go. Now my switch is a little bit wonky. Is it touching? Doesn't look like it's touching. Okay. Now that's where I finally want it. I can do the other side. But now that side wants to bridge. I have a hot mess of a button. Static forces. Okay, there we go. It's not pretty, but that should do. My button is soldered on, so it's a bit blobby there, but I think it should do. And the button is sitting pretty flush with the PCB. Now, if you have a multimeter available to you, then naturally you want to just check that. So here's a cheap multimeter. Touch my contacts, my resistance goes down. We have continuity, which is good. I'm going to touch my two pins. I have No continuity between them. Nothing. And then try and use these like chopsticks. So touch between the feet, nothing's happening. And then I press the button. We go down, I lift the button, I press the button, I lift the button. Okay, it works. So now our reset is done. Done and dusted. All of our switches are in, and what I'm going to do is I'm going to unplug my iron and then tin the tip to give it a protective layer. Go, just got to let that cool off so that the blob hangs around. And now we bring back our screws and standoffs, and then we're going to need obviously a screwdriver as well. Screwdriver. It's actually holding thermal mass really well because the blob of solder on the end here is still actually quite liquid. And until it stops jiggling, that's when I can actually put it down. I don't want to blow on it to try and help cooling it down, because if I blow on it, I can blow the solder blob off it, and then it defeats the point of what I'm doing. Now this is, I know a lot of people don't do this, and it's a bit of a pain because obviously you got to hold it till your solder cools and all that, but it does help protect your tip and stops it from corroding and whatnot. And it just increases the general life and longevity of your soldering iron tip. Okay, there we go. That can cool off properly now. So let's put some screws through this. If you're doing this without a plate, then naturally you're not going to be having to do this because you'll put it through the actual PCB. But there's plenty of clearance, so if you want to use thicker feet, thicker standoffs, then you can, but yeah. And you might say, why am I doing this video when this pad is not actually easily readily available? It is actually available. You can go to PCBWay and actually order it direct from them. I don't know how much it costs. I don't know what the shipping is going to be because it's through their shared project system. But if anyone does actually order it, please, by all means, let me know. Put a comment in below so I know what we're talking about. Because if I try and order it, it's a little bit different because I'm paying fabrication costs and no profit margin on top, but I have to have MOQs. So it's exactly the same as if I'd actually ordered it like I did before when I got this. So I don't know what the costs are when you order it direct and you're not the creator, because they're obviously going to slap a margin on that for a retail point of view. And getting these sticker things on is off, sorry, seems to be a royal pain. How do you even do this? Is there an easy way? I don't want to scratch the acrylic naturally, but it's got to be an easier way to do this, people. Just gonna pull at it with my thumbnail until a bit of it lifts. There we go. It's one side off. I can do the other side later, I suppose. So this is when I will need to use the screwdriver. Don't want it too tight, otherwise I run the risk of actually cracking the acrylic, which you never want to do. Hopefully these holes line up okay. Lucky last. We're done with that. Now I want to take the acrylic film off. There we go. Look how beautiful that looks with that clear acrylic. It's fantastic. Now let's bring my keycaps back over so I can go out of the way, and then my bump-on feet I can go out of the way. So let's put some little tiny feet on this so that it elevates off the screw heads. I like to put them on the inside. That's it, it's done. Now these are 3mm acrylic plates, and you'll see that I've got 12mm standoffs, which are perfect because the actual pins for the Pro Macro just clear them. Just clear that 12mm. I don't know if it's going to focus very well there or not, but I don't have to trim or cut any of those feet. And I know that some people do, but I don't. I prefer not to. Now let's get some keycaps on there. The reason why I'm doing this strange orientation, you probably can't see it very well, is but these actually have some homing dots on it. And I thought, might as well put them in that so that they're evenly spaced. So there you go. There is the NavPad, originally designed as the arrow keys with page up, page down, as well as your insert, home, delete, and end. And then of course these two, now that I'm no longer using them for page up, page down, can be other functions. So that was the original design intent. You can certainly use it for, you know, gaming if you wanted to, lean left, lean right, weapon classes, whatever it is that you want to do with it. And let's check if this Pro Micro will even light up. There we go. So it's powered. It seems to work. Provides a little bit of an underglow to it. You can see the green and the red as I tilt the acrylic. So nifty. Right, that is the NavPad from start to finish with all my incessant talking. It only took me about 50 minutes, including explaining everything else and setting up the diodes and all that kind of stuff. So if you were to build something similar of this size and nature, it takes you less than an hour to put it together. A bit of confidence in your soldering skills can help as well. And of course, if you weren't going to be using these kind of plates and you were just going straight in for a PCB build, it would be even faster because you're not screwing those components together. Okay, well, thank you very much for checking out the video. If you know somebody who is interested in potentially getting a NavPad or needs something of this size with 12 switches in it, easy to build, relatively low cost, please hit share on the video and, you know, send them the link and so on and so forth. If you like watching more builds like this and customs and stuff like that, please hit like, because obviously all the likes help us gain visibility. And yeah, if you have any thoughts or comments or suggestions in regards to future designs, builds, so on and so forth, please leave them in the video as well. Don't forget, we have a podcast series on mechanical keyboards at www.theboardpodcast.com. We now have an Instagram account, we have a Patreon support page, we have Facebook. So we're all over the place, as you can imagine where we would be. And yeah, all your love, support, comments, suggestions is well appreciated. So thanks for checking out the video again, and as usual, until next time, happy clacking.